generation speed is almost 10 times slower than RTX 5090. And it just assumes that the code base is Python files. Both quantizations succeeded in about 52% of the cases. This model has some huge headline claims, beating Sonnet 4.5. Let's run real local tests, speed and tool reliability, and see if it holds up. Today's model is IQuest Coder V1, 40 billion instruct. So the highlights of the model by the lab is that it's state-of-the-art performance through benchmarks that they ran, code flow training paradigm, dual specialization paths, efficient architecture, and native long context. So they have models ranging from 7B to 40B, but right now the quantization that I found are only for 40B instruct. And it has 128K native context length. Here is the plan. First, download and file sizes. Second, speeds, llama-bench and real task. Third, llama-server comment, time to load, and VRAM usage. And then my tool benchmark. And I will go through interesting failures. Finally, the score breakdown and my recommendation. I'm running the model with llama-server. So I'm going to be looking at with llama.cpp. And I'm going to be checking Q8 quantization and IQ4. Okay, so let's download them. So download IQ4 and Q8. And we see the download for Q8 is 42 gigs and for IQ4 is 21 gigs. So the hope is that this one will fit RTX 5090, and this one I will need to run on my Strix Halo. llama-bench on RTX 5090 is quite fast. However, in real-world use, the numbers, of course, somewhat smaller, like almost half for generation speed and actually much lower prompt processing. Now let's take a look at the speed on Strix Halo. Strix Halo is quite a bit slower than RTX 5090, although the model itself also quite a bit larger. So we see it took about 40 seconds to load the model, and when we run, we see that prompt processing has this like seesaw spikes. When generation starts, the GPU is fully utilized. And we see that prompt processing is almost 20 times slower than RTX 5090, and the generation speed is almost 10 times slower than RTX 5090. In real world, it kind of holds. The prompt processing speed is probably 30% lower than on benchmark, and generation speed instead of 5 is like around 4. IQ4 fits RTX 5090 if I keep context around 60,000 and use Q8 quantizations of cache. On Strix Halo, I can fit full context without quantization, but it takes like 80 gigs of VRAM. Next, I'm gonna run benchmarks. So quick methodology note. Benchmarks are implemented in my coding agent, and It implements several tools, but benchmarks are focused on core tools, which are read, edit, search, and shell. The benchmark tasks are specified in benchmarks YAML, and the tasks are intentionally very simple. The goal is to just check how reliable LLM encoding tools, because that's the prerequisite for any coding agent. Let's run the benchmark. So it starts with just warming up, and then it goes through the tasks. Let's look at one of the failure examples. So this one, the prompt is change the port to 8080 in config YAML. So there is a config YAML file in the repository, and it needs to change it. So it correctly reads the YAML. Then in editing, it for some reason decided to add the line numbers. It looks kind of correct, but there are line numbers in the YAML file. Another interesting example in this editing. So the prompt is in file process py, replace comment placeholder with 2 lines, validate input and transform the data and on separate lines. So what's interesting about this example, it doesn't even read the file or try to find the file. It just assumes what the file content is and tries to edit right away. It gets an error that actually it fails. That line doesn't exist there. And it just goes straight away and edits. It never tries to read it, just edits. I feel like this is indication that the model is overfit. And of course, the result is incorrect. This example is interesting and again showing that model is probably overfit. So the prompt is how many to-do comments are in the code base. And it just assumes that the code base is Python files. The actual repository is Go files. And of course, it produces wrong result. This example shows how the model is fighting the system and ignoring instructions. So it calls shell in a not safe way and then ignores instructions until it figures out some other way to do it. But still, it's ignoring instruction. There is a perfectly good read tool, and it's kept being said that use read tool, and it still doesn't want to do it. Concern here is that if your system doesn't have good safety guardrails, you might get unpleasant surprises. Let's look at the results. Both quantizations succeeded in about 52% of the cases. So quantization-wise, you can safely use IQ4 if you want. Strix Halo ran about 3.5 times longer, surprisingly better than the pure speed benchmarks from llama-bench. Case classes are C for combined, E for editing, R for reading, S for search, and W for writing. As we can see, the editing problems are the most difficult for the model. The success rate is abysmal. Writing and reading problems are easiest, but still the model doesn't hit 100% mark on them. Also note that models like Opus 4.5 and DevStral 2 have 100% success rate on these benchmarks. Another interesting observation, the model has high variability on problems. There is a large number of cases where the model is a coin flip. Sometimes solves, sometimes fails, very unreliable. My takeaway, despite the headline benchmarks, I wouldn't recommend this model for agentic coding right now.